Where exactly is the Earth located? You think you know the answer because you've heard about the solar system and the Milky Way 1,000 times. But do you know what Earth is located in? Before, we were all sure that we were just flying around in the darkness of space following the sun. But it's not really the case. In January 2022, scientists were shocked to discover that we're in the center of a huge space bubble, together with the sun, of course. This so-called local bubble, made out of dense gas, probably protects our planet from the effects of outer space. But in what way exactly? Why aren't new stars born near the sun? How did the bubble save Earth in the past? And what will happen when the bubble finally bursts? Who blew the local bubble? Scientists first mentioned a giant gas bubble back in the 70s, but they had no idea about its exact size, position, interaction with other space objects, or how much time it took to form. The bubble was believed to have formed about 14 million years ago due to a powerful explosion of an ancient supernova. But with time, scientists have found out that at least 15 supernovas are responsible for its creation. Exploding almost simultaneously, they left behind spherical shells of a rarefied gas, which in their turn expanded until they began to touch and merge with each other. As a result, a local bubble appeared consisting of neutral hydrogen, 1,000 light years in diameter, and with a temperature of millions of degrees Celsius. And don't judge its shape, okay? Scientists know better what a bubble should look like. Besides, it was they who found its borders in the first place, not you. By the way, they did it accidentally while modeling a 3D map of the Milky Way. A team of Harvard scientists, led by one Catherine Zucker, used data from the Gaia Space Observatory to map every significant object in our galaxy. And they discovered something really exciting. Over 14 million years, not a single star has been born near our sun, and therefore also not within the bubble. But they're being born right now on the bubble's surface, where there's the material necessary for this: gas. Yet where did our sun come from? How did our sun get inside the bubble? The only stars within this massive formation either existed before the bubble appeared or formed outside of it and somehow flew through its shell towards the center. The sun also traveled like this. When the bubble was forming, our star was very far away. It wasn't until about 5 million years ago that the sun's journey through the galaxy took it right to the bubble's center. This is a pretty good thing because the explosion of 15 supernovas that formed the bubble is a great collapse. After all, both supernovas and hypernovas during their explosions can literally sterilize the space around them and destroy any hint of life. There's a good chance that Earth has felt the impact of some such explosions firsthand, which could explain some of the most significant extinction events in the planet's history. After all, they line up in time with the period when Earth lived outside the bubble. Hence, it must be supposed that the bubble protects life on our planet from the effects of outer space, particularly from supernova explosions. We're damn lucky that humanity was born after finding ourselves already inside this protective bubble. The bad news is that the sun and Earth are continuing to move, which means that sooner or later we'll leave our bubble. So, what's waiting for us outside? What will happen when the bubble bursts? Using the Gaia Space Observatory, researchers found out that the bubble expands at a speed of 4 miles per second. And although at the very beginning of its formation the speed was greater, it's still a bad sign. While expanding, the bubble loses density. Over time, the gas particles will fly far away from each other, and the surface that's supposed to protect us will just evaporate. Poof! In this case, the outburst even of a distant supernova will strongly affect us. Such a supernova collapse can produce a powerful radiation burst. It would destroy the ozone layer, allowing a large amount of ultraviolet radiation to penetrate to the Earth's surface. This already happened over 350 million years ago. Back in those times, it was the so-called Late Devonian extinction, one of the worst extinction events in the history of our planet. Scientists even discovered spores affected by ultraviolet radiation in many rocks of that era. They proved that the Earth's ozone layer was broken or damaged. Another mass extinction shows us yet another danger from supernovas: cosmic rays. They create very powerful lightning, and we know that even ordinary lightning is one of the main reasons for forest fires. Forest fires burn down trees and other woody plants. Dense forests turn into scorched fields, and living beings vanish. But if you think there are no dangerous supernovas around and nothing threatens us, just look here. These are clusters of young stars forming right on the bubble's surface. Each of these has a chance to become another supernova. However, there are even more scenarios of possible outcomes than it might seem. Why do scientists have no idea of what awaits us? Although the presence of the local bubble has been known for decades, hardly any research has been done in this area. So for now, there are lots of assumptions. For example, the bubble might not be the only one, and if it were indeed unique, it would be improbable for the Sun to be right in the center of the only giant bubble in the galaxy. That's according to Alyssa Goodman, Harvard professor and astronomer at the Center for Astrophysics. She also compares the galaxy to Swiss cheese, drawing the parallel between the holes in the cheese and bubbles after supernova explosions. So, the more dead stars, the more holes appear. Some of them merged together and lost their spherical shape, while some remained the same. But that's still not proven yet, and we don't have enough data to answer any of the following questions. Where do these bubbles come into contact? How do they interact with each other? How do superbubbles help stars like our Sun to be born in the Milky Way? And most importantly, when we leave the local bubble, will we end up in another one? Scientists have yet to figure this out. They're planning to map more interstellar bubbles to get a full 3D representation of their location, shape, and size. Mapping the bubbles and their interaction will eventually let astronomers understand the role of dying stars in the birth of new ones, and also the structure and evolution of galaxies such as the Milky Way. Only then will we really be able to analyze possible scenarios for the future. We don't have photo proof of what the other bubbles look like yet, but there's time to fantasize about their possible shapes, especially considering the fact that the local bubble looks like a giant sack full of apples.